examples using DeMoivre's theorem. These are a bit different than the other examples we did because DeMoivre's theorem, notice, is written for if you have a complex number written in trigonometric form, and this is just a complex number. It's not written in trigonometric form. It would take a very long time to do this to the 10th power, which means we would have to write out negative root 3 plus I, negative root 3 plus I, negative root 3 plus I 10 times, and then one at a time multiply all of that out and simplify. So we still would rather do DeMoivre's theorem. To start, however, we do have to change this to trigonometric form, which means we need to do a few things. First and foremost, find out where you are, which quadrant you're in. Recall that this number here is x, and the number in front of our I is y. So our x is negative root 3, our y is positive 1. So we're going negative root 3 to the left and up 1, which is about there. The exact location isn't as important as the fact that we're in the second quadrant. We need to know that for our angle. Okay. We also need to find r. R is the square root of x squared plus y squared. Okay, so it would be the square root of negative root 3, is our x value squared, plus 1 was our y value. Root 3 squared is 3, and 1 squared is 1, and 3 plus 1 is 4. Finally, the square root of 4 is 2. So in our trigonometric form, our r is going to be 2. I'm going to start writing it down over here. Then I need cosine of an angle plus I sine of an angle. We need to find out what our angle is. So we use the fact that tangent of the angle is equal to y over x. Okay, this is from when we did trigonometric form before this, so this should be a bit of a review. Our y value was 1. Our x value was negative root 3. We want to find our angle theta, so we are going to do the inverse tangent of both sides so that we can remove tangent and just have our angle. Now again, you want to be careful on this step. Don't just automatically write this number down as your angle once you get it. Okay, so here it removes my tangents and I get theta equals and I get negative 30. Okay, now this is where you have to be careful. All it did was give me a reference angle to work from. Negative 30 is down here. We want that angle, that same angle, but in the second quadrant, which means we want the angle that's 30 degrees away from the x-axis in the second quadrant. So we take 180 minus 30, and we know that we have a 150 degree angle that we're working with. Okay, so it's important to decide what quadrant you're in. So we are doing 2 cosine 150 degrees plus I sine 150 degrees. And again, what we did there was we converted it from a complex number into trigonometric form. And now we want to take that to the 10th power. This number and this number here are the same, just one is in trigonometric form and one is just written as a complex number. All right, now we're going to use DeMoivre's theorem to calculate this value. DeMoivre's theorem says you take your number in front to your power. So our number in front, r, was 2. We're going to take 2 to the 10th power. Times, we're supposed to take cosine of that number, our power, times our angle. So cosine of 1500 plus I sine of 1500. How did I get 1500? I took 150 times 10. We were supposed to take our angle times the power. Same there. Here, 150 times 10. That's what the formula told us to do. All right, so 2 to the 10th is 1024. They didn't specify exact value or not exact value. Let's locate or see, cosine 1500 is 0.5, okay, which means that this is probably one of our exact values. So let's locate the angle 1500 degrees. just to be sure, because we can write exact values for this one. Okay, well, 1500 means we must have gone around the circle several times. So to find out how many times, I'm going to divide it by 360. And I get it goes around 4 times with a little bit left over. Okay, so that means our angle started and went around 1, 2, 3, 4 times, and then went up a little bit further, right? So let's take 360 times 4 to find out how many degrees that would be. Again, this is all kind of background work that we've done in the past, and we're just bringing it back in to help us. Okay, that puts me at 1,440, and again, I need to go clear to 1,500. So what's the difference there? 60 degrees. Okay, so I basically have a 60-degree angle. I went around the circle 4 times first, but it still has the same value as a 60-degree angle as far as sine and cosine go. So I know the exact values for the cosine of 60 degrees. Right? The cosine of 60 degrees is 1/2. And the sine of 60 degrees is √3/2. I can go ahead and distribute the 1,024. That would give me 1,024 divided by 2 is 512. Plus, if I distribute here, I can still divide the 2 and 1,024. It'll give me 512, but I'll still have the √3, and I will still have an I on the end. So there's the exact value for this. It's 512 plus 512 √3i. So a little extra work there because we had to convert it to trigonometric form, and we also had to find out where this angle was for exact purposes, but we came out okay. All right, so here's another example. We're going to evaluate -1 plus I to the 6th power. Okay, this one, we again need to very first, so you don't forget, I always locate which quadrant I'm in. So -1 takes me 1 to the left, that's my x, and +1 here, up 1. So I know I am in the 2nd quadrant. All right, from there, I also need to find my r, which is the square root of x squared plus y squared. So that would be the square root of -1 squared plus 1 squared. 1 plus 1 is 2. So my r is √2. So this is going to look a little funny. Then I have cosine of some angle plus I sine of that same angle. To find our angle, we use the fact that tangent theta is equal to y over x. So that gives me tangent theta equals, my y is 1, my x is -1. Tangent theta equals -1. Then I take the inverse tangent of both sides to remove the tangent so that I'm just working with theta. On this side, the tangents cancel, and I get theta equals, if you use your calculator, it gives you -45 degrees, which would be down here. I know I need to be up in this quadrant here where the tangent is also negative, and I know now that I need the angle that's 45 degrees away from that x-axis, which is where 180 is located. So I go ahead and do 180 minus 45, which is 135 degrees. So my angle that I'm going to be using is 135. So over here, I have cosine 135 degrees, sine 135 degrees. Whew! Step 1 done. I changed from complex to trigonometric form. Now I need to raise that to the 6th power. I'm using DeMoivre's theorem, which tells me to raise the number in front to my power. So I have the square root of 2 raised to the 6th power times the cosine of, I take my angle times my power, so 135 times 6 plus I sine 135 times 6. Okay. Root 2 to the 6th power, you can go ahead and calculate that on your calculator, and it should give you 8, because really this is 2 to the 1/2 power. If you raise that to the 6th power, you get 2 to the 3rd, or 8, which again, you can just use your calculator to calculate that number. Okay, here I get the cosine of 135 times 6 is 810 degrees, plus I sine 810 degrees. And I'm just going to do a quick check to see if that might be one of my exact value numbers. And when I do the cosine of 810, I get 0. Okay, so that tells me I have either a 90, go around the circle and then come to a 90, or go around and come to 270. Here, I'm going to do the sine of 180, sine of 810, dyslexia hit me right there, and I get 1. So I get 0 plus I times 1. Well, 0 plus I times 1 is just I, so I get 8 times I, or 8I for my answer. Now, the reason I didn't go ahead and break that 810 down is because its exact values weren't the square root of 3 over 2 or the square root of 2 over 2. It was just 0. So I knew the other one would probably be 1 or -1. So I didn't worry about figuring out what reference angle I was working with. I just used the calculator.